Week 24, 4th grade, tree rings. Teachers, we're going to wrap up our unit on plants with some tree cookies and reading the rings of a tree and figuring out the age of it and what happened to the climate over a period of time. So what I'm going to have on the students' tables is a pine tree cookie. The Forest Service makes these for us here in Lufkin. And I will have these in plastic sleeves because I don't want the kids to take pencils and make marks on these, because over time they'll ruin the tree cookie. So they'll be in a plastic sleeve. I have different kinds. They're all pine trees, but they're harvested at different locations, so they look different. So let me start with this one right here to show you how to read a tree cookie. This part right here in the middle is the germination of the tree, the sprouting of the seed, that first growth when it starts coming out of the ground. So we don't count that one as a year. The distance between this what they call the whitewood growth, like this is whitewood, this is darkwood. This is a year right here. This is a year. At the end of the growing season, the wood begins to darken because it's going into its dormancy. So if we want to count this accurately, we're going to count the dark rings. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This tree's 12 years old. So you don't count all the way across, you just count from the center out. And I know in math that you could use your things like radius, you don't do the circumference, and use those terminologies like that. This tells scientists that over the last 12 years what the rainfall was for that region where this tree was harvested. So students could look at that whitewood and say, well, there was a lot of rainfall this year because there was a lot of whitewood. Then you move to an area like this right here, and maybe there wasn't that much rainfall here. Maybe we were in a drought, but I wouldn't tell them that. I'd ask them, so what is the occurrence when there's not very much rainfall in an area, when it falls below normal? And they should know that's a drought. What happens when there's a lot of rainfall and there's too much rain? The kids should pick up that that's flooding. This little tree cookie right here shows enormous growth for about 1, 2, 3, 4 years. For 4 years, there was a lot of rainfall for this tree. And then towards the end, before it was harvested, you can see that it probably slowed down to normal. Since you look at these other rings here and you kind of see what a normal tree ring looks like, then this is actually normal. This is very fast growth. Now these are pine trees because pine trees grow extremely fast. If you're looking at a hardwood ring, your rings are very tiny and close together and they're very hard to read. That's why we use pine here to make it easy for the kids. So that's what we're going to do with this. And of course they can look at these and see the bark. And that it is a smooth surface because they sand them and polyurethane them for us. Alright, and then we're going to move from looking at those and finding out how old those tree cookies are to this. Everyone's going to have 4 tree ring pictures that I got off the internet. One's from Columbia, one's from Boston, one's from Seattle, and one's from Jackson. And they're going to be able to take these and count these rings and do a little math problem here. So they're going to count their dark rings, and I'm not going to count all these for you. You know what I'm doing. And I have worked up a little sheet here, like on Columbia. It tells you on the sheet, this tree was harvested in 2005. So I'm going to go to my Columbia sheet right here. I've got my year harvested, was 2005. I'm going to count my rings, so how old is it? And then I'm going to subtract. I'm going to find the year it was planted. And I'm going to do that on each one of my locations. So they have 4 math problems for them on these tree rings. And then we'll see how they do. And they can tell by looking at these rings that from different locations that different things happen to the moisture in these areas. And that's just a good activity for them to learn some good math that scientists actually use. This is a tray of borers. When foresters don't want to cut down the tree to find out how old it is, they have an instrument they use to bore a hole into the tree. And they pull out this bore core, and they take it back to their office and they count these rings to find out how old it is. I mean, it doesn't do a lot of good to cut down a tree to find out how old it is after you kill the tree. So this is how scientists do it most of the time to keep their trees alive. A forester came out and did this on several trees in our outdoor classroom, and I saved these because they're real brittle. I don't want the kids handling these because I've got them taped in. But that's just a way that foresters do it and not kill the tree, because they might ask, well, do we always have to cut down a tree to find out how old it is? And the answer is no. You can do a bore sample and count your rings on your bore sample. So we're going to do a little math problem. We're going to look at the tree cookies. And then I have some leaves also out for your kids to look at. I have, these are trees from our outdoor classroom. And I laid these on a color copier when they were green. And it just makes you a nice copy of a green leaf. And like right now in February, we don't have any green leaves. So it gives you access to nice green leaves that are really real life leaves that are around our school any time of the year. So I have a copy of these, and I'm going to have these little books available. We have these little flip books right here, several of these, and these trees are actually found at the back. This is a sycamore leaf. This one right here is right here in the book, and it's a eastern red cedar. And then the most common tree we have, which is what our forest is noted for, is the loblolly pine, and it's also in here. It's not a very good picture in this book, because this book, when they look at it, they're going to find that there's trees that grow in California and the north and the east. So they're all over the United States. But these are just good little ID books that we're going to use just to get kids noticing that we classify leaves by their shape first. And then we start honing in on what other things, characteristics they have. So, math problem, tree rings. Then we're going to make their own tree cookie. And what I've done is I'm going to give you a paper plate. And I did this ahead of time because I found it's very hard for me to draw and write and talk at the same time. So I took a paper plate. I put me a green mark. I put my birth date. And then what did I do the first year? Well, you learned to walk. Now, these can be anything they want to write, but they're not going to remember what they learned the first year. So you might have to help them. Babies learn to walk. Second year, they learn to talk. And then I just made all this up. I got a dog. I don't know what they're going to write. Maybe I learned to ride a bike. 5 years old, I started school. 6 years old, I lost a tooth. Maybe the next year I played in the All-Stars. Or maybe I danced in a recital. Then we got the student's name here. And how old this tree is, which is them. And you can put them all up out in the hall next to each other, and you'll have a bunch of tree rings to look at. So let them do the writing, the circling. Do this. You can do this either in the science lab or take this back and do it in your classroom.